So a couple of the megatrends that are affecting distribution utilities today include the proliferation of DERs, or distributed energy resources, as well as the proliferation of electric vehicles. The proliferation of distributed energy resources, such as solar power and energy storage, are introducing voltage fluctuations into the grid, and we're already seeing that today in isolated or islanded systems. The proliferation of electric vehicles are introducing loads where there weren't large loads before, both as spot loads, let's say in fleet electrification, and as distributed loads, let's say as light-duty vehicles are charging in a residential area. So it's important to monitor the proliferation of these DERs, both in existence and also their behavior for planning and operations within a distribution utility grid. So one of the problems monitoring the proliferation of these DERs and the low voltage circuits are that there is no instrumentation and there is no visibility to these DERs. So it's very difficult to determine whether or not, for example, an EV, electric vehicle, exists behind the meter. A customer would have to tell a utility that they have a level 2 charger, for example, for a utility to know today. Awareness of these distributed energy resources and electric vehicles in low voltage circuits can help defer capital infrastructure upgrades, especially through indirect control, such as rates for EV owners or different tariffs for solar owners, and also through direct control, for example, through demand response or peak shifting. Another thing that awareness does is it can help a utility move some of its operations and maintenance costs, or O&M costs, to capital projects, which better help with a proactive approach versus a reactive approach, and is ultimately many times better for the ratepayer. Some of the components that Itron offers to realize the value of monitoring low voltage circuits include DER Optimizer, or DERO, EV Charging Optimizer, or EVCO, and Grid Edge Optimizer, or GEO. Each of these three solutions can help solve some of the industry's low voltage network challenges. So our distributed intelligence solutions compose GEO, or Grid Edge Optimizer portfolio, and it includes applications such as high impedance detection, location awareness, and electric vehicle awareness. Some examples of distributed intelligence results are seen in high impedance detection and location awareness. High impedance detection, we've seen over 90% accuracy in determining and identifying problems between the meter and the distribution transformer that would eventually result in an outage. For location awareness, we're seeing over 90% accuracy in meter to transformer relationships. In addition, location awareness provides meter to phase and meter to transformer relationships. Another example of a near-term use case that the Grid Edge Optimizer addresses, EV awareness provides the visibility to EV behavior, which helps utilities control other loads or the EV loads themselves in order to combat things such as peak loads at certain distribution transformers. But in addition, it also helps with future scenarios such as vehicle to grid, in which an electric vehicle is not only a large load, but could also be a large source of power on the distribution grid.